Okay, I think we're going to title this video here, a little bit of maintenance on the Copper Electroforming tank and system. I want to show you some of the components of this system. This is an air pump right here. This is used for the air that agitates the tank. The reason you see the motion through the side of the tank there in the liquid in the plating bath is because of the air that we're pumping in through a tube called a sparger. Just a piece of PVC along the bottom of the tank with a bunch of holes in it. I'm going to turn off that air. Okay, turning off the valve that controls the air. And now let's turn off the pump. This is actually a large aquarium pump, a pond pump that we use for our agitation air. And we'll just unplug that. Let's see. Still kind of noisy in here. I'm going to turn off the lab air ventilation, the big fume hoods, just to quiet things down a little bit. Just to the left of the door as we walk into the Chem Lab. Okay, turning them both off. Okay, the noise you're hearing right now is the circulation pump that we run on the tank. Circulate the bath a little bit for the sake of agitation around the piece, but mostly for filtration. This is a filter that we're running right here. Part of the maintenance operation I want to do right now is because of this. You see we've got a small leak at the top of the filter. It would be a real, I'd say, a rookie mistake to want to work on that filter without draining down the tank. The tank normally runs with a plating solution at about the level of my hand right there. But yesterday I came in and set up a siphon, and I siphoned out about half of the tank, which is just down in these used glass bottles, isopropyl bottles that I washed out with water, so they should be nice and clean. I don't want any contamination getting into the tank. We've been running this tank and pump for about 10 years now, and it's been quite reliable, but it is a sulfuric acid solution that you're running in the tank and pumping around, so you tend to get a lot of corrosion. Copper sulfate salts tend to build up. Let's see, I'm going to turn off the pump. Quiet things down a bit more. As you look inside the tank, you see the copper anodes that are in each corner. We buy those from a company called Univertical, and they're just attached to the side of the tank with a, I think it's an 832 or maybe a 1032 screw and a wing nut. Drilled holes through the side of the tank and put a little rubber O-ring on there to try to seal things up a bit. We could have one in this corner right now, but we don't. We don't really need to have 4 anodes in the tank. Typically 2 or 3 is adequate for the size of the parts that we work with. You do try to maintain an anode to cathode ratio in a particular range that the manufacturer specifies for the process. So basically the configuration here is a hose coming from the pump. Notice that this hose rises up well above the fluid level in the tank. There's the top of our tank. Pan over to the hose. There's the hose. And it goes up about another 2 feet. That's important so that if the pump were to fail or we turn the pump off and have forgotten to close that valve, you won't get a flow of the plating solution all the way back to the pump. You know, liquid will find its own level, so you would get a flow up to about maybe this height in the hose, but you've still got 3 feet of hose above that. Just want to be sure you're configured so you can never get plating bath back into the pump. I'm sure that would destroy the pump almost instantaneously if that were to happen. There's our pulse plating supply that we use sometimes. If we want to do electroforming on a part where we need to throw copper down into a deep recess, phase shifters would be the example of that, where you've got the fins on the phase shifter look like that, and you would like to fill in with copper as deeply and completely as possible. And that's what pulse plating does for you. Basically just run a 50% duty cycle at a few hundred hertz and you get much better filling. Another feature of the system here, we've got a little metering pump up on the side of the wall, the back wall of the fume hood. That solved a problem that we had years ago with trying to run the system over the weekend unattended. One of the additives, one of the plating additives, is depleted fairly rapidly. It needs to be replenished on at least a daily basis, maybe even twice a day, depending on the size of the parts and how much current you're running. So we added this little metering pump. We can set up a beaker of our additive, although typically we dilute the additive about 10 to 1. So 100 milliliters of additive, which is known as maintenance, the maintenance additive to the 2X plating solution, plating process. So 100 milliliters of additive to 900 milliliters of water, so you've got a 10% solution. The metering pump runs at about 25 milliliters per minute. So if you run that pump for 4 minutes, you'll put 100 milliliters of solution into the tank through the discharge hose. Here's the discharge hose that typically runs in through a hole in the top cover of the tank, which we don't have on there right now. So run that pump for 4 minutes. You're going to pick up 100 milliliters of solution. It's a 10% solution, so with 100 milliliters you've got 10 milliliters of the maintenance additive, which if you do that on a daily basis, that will pretty much keep the process running well. Although you might need to adjust that level of additive depending on the size of the part, how many parts, and how much current you're running in the plating process. So how do we control this metering pump? Well, we had this beautiful Sylvania lamp timer that unfortunately died on us, but we found a similar lamp timer on Amazon for 20 bucks. It's very nice, digital. You can program just 2 on-off times per day, but that's enough for what we're doing. So you just set this up so that you get a couple minutes at midnight, a couple minutes at noon, or a couple minutes at 6 in the evening, a couple minutes at 6 in the morning, giving you a total of 4 minutes of run time and 100 milliliters of solution from that beaker containing 10 milliliters of your maintenance additive for the tank. A nice feature of this little timer, I've checked it with power off for about 3 days and it was maintaining the clock. So either it's got a super cap or a battery in there, so it'll certainly ride out any short power failures that we do get around here at times. So really what I've done starting yesterday was just drained half of the tank so that I can disassemble this filter housing, clean things up there a bit. I think I'll do a little bit of work on the stainless steel strapping that ties all the anodes together. You know, the anodes are all connected to the positive side of our power supplies down here. It's a nice little Hewlett-Packard power supplies that we run in current mode as current sources. And we have a separate supply for each plating station on the tank. If the top was on, you see we have 4 positions on the top of the tank where we can drop electroforms into the tank for plating. So we run a separate supply for each piece, and we run in current source mode, so we definitely know the current that we're getting into each part. Much better than trying to run say a voltage supply that's going to split between 2 or 3 parts. And then when the top of the tank is in place, we have these little piece rotators that I built years ago. These run with a 1 revolution per minute clock drive motor. By spinning the part around, it's suspended from, let's see, you can see the little coupling there, little coupling that comes down from the motor. We run a 1/8 inch diameter stainless steel rod from that coupling down into the part that we're electroforming. Got a little, probably don't need it, but a little electrical brush. So we're actually energizing the component, driving the current in through this assembly. That's how we drive the plating current into the part, hanging down on a stainless steel rod from the piece rotator. And these have worked out very well. Although I'm starting to have problems with some of the wiring dying on a couple of these. I think I'm going to replace these motors. I don't have any of these 1 revolution per minute motors, but I've got a couple that are actually 1 revolution per hour. And I suspect that'll work just fine too. All we're trying to do is maintain uniform plating on the part. You do not have a symmetrical current distribution naturally within the tank, because the anodes are in the corners. If you had the parts suspended right in the middle of the tank, you would have a natural even current distribution, assuming you had 4 anodes, 1 in each corner of the tank. But we don't work right at the middle of the tank. We want to have 4 stations in here, so we're off at the corners. But by rotating the part continuously while it's plating, you maintain an average uniform current distribution and plating rate around the entire part. That's the reason we can plate a component like this and get a very perfectly uniform distribution of copper around the piece. Okay, so I've actually covered quite a bit about our copper electroforming in this video, and I hope that's of some benefit to you at some point in the future. Okay, Jerry the Plater, signing off.